Bismillahirrahmanirrahim. Assalamu alaikum everyone. Welcome to Khan Lectures. Before I start today's lecture, I want to ask you a simple question. Imagine you want to teach an intelligent robot to read and understand a novel. Let us say a Pakistani Urdu novel or even a novel in English written by Pakistani author like Mohsin Hamid. Where do you begin? What do you actually give to this robot? What material does it need and in what form? Think about it for a moment. You cannot just tell it to read it. A machine understands nothing until you convert language into a form that can be processed by a machine. A machine understands nothing until you convert language into a structured machine-readable form. That conversion from natural human language into structured computational data is exactly this video is about. Today we are covering the topic language is data, corpora, text, and linguistic annotation. This lecture has four main parts. Part 1 covers what is corpus and why do we need it. Part 2 covers types of corpora and their uses. Part 3 covers linguistic annotation in detail. And Part 4 is our practical demonstration using Python or NLTK. Let's start. Part 1. What is corpus and why do we need it? Let us start with the most basic question. What is corpus? The word corpus comes from Latin and it simply means body. In linguistics, a corpus, plural corpora, is a large structured collection of texts in a machine-readable form. That is the technical definition. But let me explain it in a way that actually makes sense. Think of a corpus as a library, but instead of physical books on shelves, every single text in this library is stored digitally in a format that a computer can search and analyze and process automatically. Definition. A corpus is a large, structured, machine-readable collection of texts used as the empirical basis for linguistic analysis. Now here is an important word in that definition, empirical. In traditional linguistics, especially in Chomskyan tradition that dominated the 20th century, linguists often invented examples. Chomsky's famous sentence, colorless green ideas sleep furiously, is grammatical but meaningless. And it was invented in the linguist's mind, not found in actual language use. Corpus linguistics takes a completely different approach. It says, do not invent example, find them. Look at how real speakers actually use language in real life situations. A corpus is the collection of those real examples. In computational linguistics, inherits this empirical commitment. When a machine learning system learns to take parts of speech or parse a sentence or translate from one language to another, it learns from real language data like corpora. Without corpora, modern computational linguistics would simply does not exist. Why can't we use just the internet? At this point, some of you may be thinking that if we need a large collection of texts, why not just use internet? The internet contains billions of pages, texts. Why go to the trouble of building a special corpora? This is a genuine question and it needs a careful answer. The internet is enormous, but it is completely uncontrolled. It contains spam, duplicate content, machine-generated text, and vast amount of low-quality writing. It has no documentation about where the text came from, who wrote this text, when they were written, or in what context. It is heavily biased towards certain countries, towards certain registers, towards written rather than spoken language. A properly designed corpus, by contrast, is carefully selected and balanced. The designers make deliberate choices, what to include, what genres, what time periods, what varieties of language, what topics. Every text in the corpus is documented, its source, its date, its author, its genre. This documentation is called metadata. Think of the difference this way. If you want to study the food habits of Pakistani people, you can stand on a busy street corner in Peshawar and observe what you see. Or you could design a systematic research study with a properly selecting representative samples of participants. Both approaches give you data, but only the second one gives you data you can trust. A corpus is systematic research study. The raw internet is street corner observation. Let me introduce you to some famous corpora. The Brown Corpus, 1961. This was the first major machine-readable corpus in English. It was compiled by Brown University in the United States, and it contains 1 billion words of American English, sampled from 500 different texts across 15 genres, from newspaper to scientific writing. It was revolutionary because for the first time, linguists and early computational linguists had a shared standard data they can all work with. The British National Corpus, BNC, 1994. This corpus contained 100 million words of British English from the late 20th century. Crucially, it includes not only written text but also the transcribed spoken language, conversations, interviews, lectures, and phone calls. The inclusion of spoken language was a major advancement because it enabled researchers to see how people write and how they speak. The Bantry Bank, 1992. This is not just a corpus of text, it is a annotated corpus. Every single sentence in the Bantry Bank has been manually labeled with parts of speech tags and syntactic parse trees. It contained 4.5 million words of American English from the Wall Street Journal. It became the standard training and testing data set for computational analysis, and its annotation conventions influenced the design of dozens of subsequent corpora worldwide. Corpora for South Asian languages. For students working on Pakistani languages and varieties, it is important to know that there is a dedicated corpora exists. Though they are smaller and less developed than English resources, the EMILL includes materials from Urdu, Punjabi, Gujarati, Bengali, and other South Asian languages. The Urdu monolingual corpus was developed by FAST University, Lahore. It is one of the most significant resources for computational work on Urdu. For Pashto, the resources are even more limited, which is itself a research problem that some of you may find worth investigating in your doctoral research. Now let's go to part 2. Types of corpora and their uses. Not all corpora are designed the same way. They differ according to their purpose, their content, their language, and their time frame. Understanding these differences helps you choose the right corpus for your research question. Monolingual versus multilingual corpora. A monolingual corpus contains text in a single language. The BNC is a monolingual corpora. A multilingual corpus contains text in more than one language. The EMILL is the multilingual corpora that I mentioned earlier. A special and extremely important types of multilingual corpus is the parallel corpus, a collection of texts paired with their translation in one or other languages. And this corpus is very much significant in the machine translations. General versus specialized corpora. A general corpus is designed to represent a language as a whole. It samples broadly across many different genres, registers, and domains. The Brown corpus and BNC are general corpora. A specialized corpus, also called the domain corpus, focuses on the specific subject area or register. Medical corpora, legal corpora, scientific corpora are all specialized corpora. Written versus spoken corpora. Most early corpora contained only written text because written text is much easier to collect and processed. Spoken language must be recorded first and then transcribed. It is a time-consuming and expensive process, but spoken language is in many ways fundamental form of language, and many linguistic phenomena, for example, prosody, interruption, hesitation, repair, informal register, can be analyzed in spoken corpora. Synchronic versus diachronic corpora. A synchronic corpus represents language at a single point in time, a snapshot. A diachronic corpus spans multiple time periods, and it allows researchers to track how language changes over time. The Google Books Ngram corpus is one of the most famous diachronic resources. It contains text from millions of books published 1500 to 2019, allowing researchers to trace the rise and fall of words and phrases across centuries. For literary scholars, diachronic corpora opens fascinating possibilities for studying the historical evolution of literary language in genres conventions. Reference corpora versus monitor corpora. A reference one is a fixed table collection used as a standard benchmark for comparison. A monitor corpus is continuously growing. New tags are added as they are produced. The Collins-Cobalt monitor corpus, which forms the basis of the Collins English Dictionary, it is a monitor corpus that contains 400 million words. The monitor corpora are particularly valuable for tracking new words, emerging meanings, and contemporary usage patterns. How corpora is related to you. Whether you work with linguistics or literature, if you are a discourse analyst, a corpus allows you to examine thousands of instances of particular discourse features, such as passive voice constructions in Pakistani newspaper editorials, hedging languages in academic writing. Now let's come to part 3, linguistic annotation, turning text into structured data. A raw text corpus contains language in its natural form, just words and sentences as they appear in the original source. But language is deeply structured. Every word belongs to a particular grammatical category, and every sentence has a syntactic structure. Words carry meanings, and there are different tags connected to these words. None of the structure is visible to a computer unless we mark it explicitly. Linguistic annotation is the process of adding structured label to the text. Think of annotation as translation. You are translating the implicit structure of a language into an explicit machine-readable form. Linguistic annotation is the process of explicitly labeling linguistic properties such as part of speech, syntactic structures, or semantic roles in a text so that these properties can be processed computationally. Let me show you a very simple example. Take this sentence. The students read the article carefully. Now, as a linguist, you know that there are so many tags connected to different words. The student is a noun phrase and it is a subject. Read is a verb in simple past tense. The article is the direct object. All the structure is there in the sentence, but it is invisible to the computer unless we mark it explicitly. Now, what is the annotated version? There are certain different abbreviations and tags developed by Pentry Bank Corpora, and it is widely used everywhere to take POS or sentence parsing. For example, DT means determiner, NNS means plural noun, VBD means past tense, and so forth and so on. If you want to learn about these tags, you can search it online and it is available on Google. This is called parts of speech tagging, and it is one of the most fundamental forms in linguistic annotations. And it is a completely standard first step in every labeling processes. Now let's talk about the different levels of annotation. Linguistic annotation is not a single thing. It happens at multiple levels. Each level has a linguistic analysis. Let me tell you some of them. Level 1, tokenization. Tokenization is the most basic level of annotation. It simply means dividing a continuous text into individual units. Tokens are words and punctuation marks. This is a very difficult process. For example, what will you do with contracted forms? For example, don't, is it one token or two tokens? What about hyphenated compound words? What about email addresses, hashtags in social media? And especially what about Urdu text in the Nastaliq form? So tokenization decisions are very significant decisions. Level 2, parts of speech tagging. After tokenization, each token is assigned a grammatical category level. Modern POS taggers are trained or annotated corpora and used machine learning to predict the correct tag based on the word, sound, and context. State-of-the-art POS taggers for English achieve accuracy rates above 97% on standard benchmark, which sounds impressive, but the remaining 3% represents enormous numbers of errors when you process millions of words. Level 3, lemmatization and stemming. Lemmatization is the process of reducing the word into its base form. The words reads, reading, read, and reader all shares the base form. Lemmatization matters for computational tasks because the machine that does not recognize these different forms is related to a single word will treat it into different items. Now, stemming is a cruder version of this idea. It simply strips out the affixes from the words. Without linguistic knowledge, reading becomes read by removing ing from it. Stemming is faster but less accurate. Lemmatization is slower but more correct. For search and information retrieval, stemming is often sufficient. But for deeper linguistic analysis, lemmatization is preferred. Level 4, syntactic parsing. Parsing assigns hierarchical syntactic structures to sentences, typically in the form of phrase structure tree or dependency graphs. A phrase structure tree shows how words group into phrases, a noun phrase, a verb phrase, or a prepositional phrase, and how these phrases combine to form a sentence. A dependency tree shows the grammatical relations between individual words. Which word is the subject of the verb, which word is the direct object, which word modifies which. Both types of parse are widely used, and we will study them in detail in the next lecture. Level 5, Named Entity Recognition, NER. Named Entity Recognition, or NER, is the task of identifying and classifying named entities in the text, proper nouns that refer to the real-world objects. The standard categories include person, organizations, occasions, dates, times, monetary values, and percentages. In this sentence, Prime Minister Shahbaz Sharif met President Biden in Washington. The NER system should identify Shahbaz Sharif and Biden as a person, Washington is a location, and the Monday is a date. NER is crucial for information extraction tasks, building databases of facts from unstructured text. Level 6, semantic role labeling (SRL). In the sentence, Ali broke the window with a stone. Ali is the agent, the one who performs the action. The window is the patient, the entity affected by the action, and the stone is the instrument. These labels are semantic rules. SRL is difficult and expensive than pure stacking and NER, but it captures deeper aspects of meaning that are essential for questioning, answering, and information structure. Level 7. Discourse Annotation. The highest level of annotation goes above the individual sentence to mark discourse level structures, the organization of meaning across sentences and paragraphs. Discourse annotation includes marking reference changes, identifying all the expressions that refer to the same entity, rhetorical relation between sentences. Is this sentence connected to the previous one or against the previous sentence? Discourse annotation is the most difficult and expensive to produce because it requires deep understanding of the text as a whole, exactly the kind of understanding that computational systems still struggles with. Now let's discuss how annotation is produced. There are two main methods for producing annotated corpora, and both are still widely used today. The first method is manual annotation. Human annotators, typically trained linguists, read through texts and add labels by hand using special annotation tools. Manual annotation is slow and expensive. The second method is automatic annotation, using trained computational models to add labels automatically. Modern tools like Spacy, Stanford Cornell P, and NLTK library that we will use in this course provide labeling words automatically in seconds. These automatic tools are trained on manually annotated corpora. So manual annotation is not replaced by automatic annotation. It makes automatic annotations possible. Yet there is another process of semi-automatic annotation in which the machine produces the annotated text and then the humans correct that annotated text if there is any issue. Part 4. Practical demonstration.